The brightest point of light you will ever see in the night sky is not a star. It's a planet, and it murdered itself. Venus is Earth's twin, the same size, the same rock, born right beside us from the same cloud of dust. For its first billion years, it may even have been the gentler of the two, mild and wet, with a shallow ocean. Today, its surface is hot enough to melt lead. This is the story of how a world exactly like ours boiled its own sky away. We call Venus our twin, and we mean it almost literally. It is 95% of Earth's width, 80% of its mass, built from the same rock, orbiting one single step closer to the Sun. It's the brightest planet in our sky, wrapped in clouds so bright they throw back more than 3/4 of the sunlight that hits them. And then you arrive. The surface sits at around 460 degrees Celsius, hotter than Mercury, which orbits twice as close to the Sun. The air crushes down at more than 90 times Earth's pressure, the weight you'd feel a kilometer deep in the ocean. And high above, it rains sulfuric acid from clouds that never break. We have actually stood there. Soviet landers dropped through that furnace one by one, and the toughest, Venera 13, held on for 127 minutes before the heat killed it. 2 hours. That is the record for surviving Venus. So how does a twin of Earth end up like this? To answer that, you have to run the clock back, maybe 3 billion years, to a Venus almost nobody pictures. The Sun back then was a quarter dimmer than it is today. And climate models from NASA's Goddard Institute find something remarkable. If the young Venus turned slowly enough, its daylit side would pile up a thick shield of cloud that held the worst of the heat off, leaving the surface cool enough for liquid water to gather on the ground. In those models, Venus doesn't merely survive. It stays mild for up to 2, even 3 billion years, which would make it the first habitable world in the solar system, comfortable long before Earth had settled down. So stand for a moment at a low Venusian shore under a pale sky, shallow water reaching toward the horizon. Listen. It's only a model, but it's a good one. And it raises a terrible question. If Venus was ever a paradise, what turned it into an oven? The machine that kills a world like this has a name, a runaway greenhouse, and it begins with water doing something completely ordinary. Water vapor traps heat. So warm a wet planet a little, and more water evaporates. That extra vapor traps more heat, which lifts still more water into the air. On Earth, that loop stays gentle and self-correcting. But nudge a world past a certain brightness of sunlight, and the loop stops closing. Every degree of warming pulls more ocean into the sky, and nothing can pull it back. The sea doesn't sink, it leaves. Up high, sunlight then tears the water molecules apart, and the light hydrogen drifts off into space. The carbon dioxide that a living ocean would normally lock back into rock has nothing to dissolve into anymore. So it builds and builds, until the sky itself weighs 90 times what ours does. That is the furnace. That is where 127 minutes comes from, which leaves the real mystery standing. Earth is right next door. Why did the loop run away on Venus and never here? The baseline answer is cruelly simple. Venus sits just close enough to the Sun to cross that runaway line. The line Earth stays safely below. But that only tells you Venus was fragile. It doesn't tell you what it actually lost. And here the science splits genuinely right down the middle. One camp says Venus truly had that ocean, stayed livable for billions of years, and only tipped over late, perhaps 700 million years ago, when a convulsion of volcanism flooded the air with carbon dioxide and shoved it past the edge. The other camp says there was never an ocean at all. Their models of the young, molten Venus find its clouds would have bunched on the night side, leaving the daylit face bare and blistering, so the water never cooled enough to fall as rain in the first place. Venus, they argue, was born a steam world, and the rock that erupts there today comes up bone dry, as if the planet spent its water before it could ever pool. So which is it? A drowned paradise, or a desert that never had a drop? For 60 years, all we've had is the argument. But Venus left a confession. It's written in the air, in a single ratio. Hydrogen comes in two weights, ordinary hydrogen and a heavier twin called deuterium. When water is broken apart and the light hydrogen escapes to space, the heavy deuterium gets left behind. So a planet that lost an ocean's worth of water should be breathing unusually heavy air. And when the Pioneer Venus probe sampled that atmosphere, that is exactly what it found. Deuterium enriched to roughly 100 times the level in Earth's water, by some measures half again more. That is the chemical shadow of a staggering amount of water gone. But here is the honest catch. It proves Venus lost an ocean's worth of water to space. It does not prove that water ever lay on the ground as a sea. The confession is real, it's just not quite a photograph. And folded inside it is the cruelest possibility of all. In 2019, a team modeling that lost ocean noticed something unsettling. An ocean is never passive. It has tides, and the sun pulls on them the way our moon pulls on ours. On Venus, those solar tides would have dragged against the turning planet like a brake. In the model, the effect is enormous. It could slow a Venus day by dozens of days every million years, winding the whole planet down toward the crawling spin it has now, where a single day on Venus lasts longer than its entire year. And a slower spin means a longer day. More hours baking under the sun, more evaporation, a harder shove toward the runaway. Which means the ocean that may have made Venus livable could also have slowed it, cooked it, and helped kill it. The victim, possibly, was the murder weapon. It's a beautiful idea, and like everything here, it needs the ocean to have been real in the first place. For 60 years, this has been models arguing with models. That is about to change. For the first time, we're about to trade the models for measurements. 3 spacecraft are being built to go back. NASA's Da Vinci will drop a probe straight down through the entire atmosphere, tasting the air as it falls, reading that deuterium confession directly, and sniffing for the rare gases that betray how much water Venus once held. 2 orbiters, NASA's Veritas and Europe's Envision, will use radar to see through the clouds and map the ground below, hunting for the shapes of old shorelines and drowned highlands. They keep slipping. All 3 are now aimed at the early 2030s, and those dates have moved before. But they are coming, and when they arrive, the oldest question about our sister world, was Venus ever blue, stops being an argument and becomes something we can finally read off the sky. So look at Venus again. Really look. The next time it burns low and brilliant before sunrise. It isn't only the loveliest light in the sky, it is a world the exact size of ours, made of the same rock, handed many of the same ingredients, and somewhere along the way, one twin kept its oceans and the other lost everything. Venus is what a habitable world looks like, after the greenhouse winds. Earth's own face, remade in fire. We built machines that lasted 2 hours on its surface. Soon we'll send more to learn whether that furnace was always a furnace, or whether it was, once, a shore. Because Venus may not be the only ocean we lost out here. The next one might still be down there, hidden under miles of ice.